Good morning, Jasper. Our group will do the presentation for the purpose of practicing and learning the fact-finding, presentation skills, and reporting skills. Also to gain a better understanding of the knowledge for medium and high-rise commercial buildings in Australia. This is our task allocation. And we basically explain from substructure and superstructure. Next, Song will explain the basement construction process.
So for the first component is boundary retaining system. So we're going to be looking at the sheet pile as the first component. The sheet pile are section of the sheet material driven into ground to prevent the backfill from entering into excavation portion. So basically just a support for the retaining wall. And as you can see from the left hand side of the image, this the typical sheet pile looks like in the construction site. And typical materials for sheet pile is steel, but can also be formed by timber, concrete, light, aluminum, vinyl, fiberglass. There's the two different rolled sheet pile. The first one is hot rolled sheet pile, use a ball and socket or lesson interlock. The second one is the cold form sheet pile, use a bent plate interlock, as you can see from the first diagram above. And there's the two different types of the sheet pile that we researched. The first one is the Z profile sheet pile. Looks like a horizontal stretched Z shape. And the Z profile sheet pile are the most efficient sheet piling sections available for bending strength. The U profile sheet pile, on the other hand, looks like a letter U. U profile sheet piles are traditionally installed as a single pile. However, this can be supplied as a double or triple pile. There's a lot of advantage of using the U profile. And comparing with two different profile, we can get the conclusion of the Z profile will cost more and delivers a greater system width, less time to consuming on the installation and handling process, and the use of the Z profile will offer enhanced water lightness by decreasing the number of interlock per meter run of the wall. And here's the installation used for sheet piles. There's the two main installation method. The first one is push down, and the second one is driving. As you can see from the photos showing the that's the one of the methods. And for second pile, which is the second component, the second pile wall are used to construct in-ground retaining walls. Because the pile are cutting to each other, they form a continual wall that can reduce water inflow into excavation in front of the wall, as well as retaining soil behind the wall. And this can be a using function as a water tightness. And the material of the second pile are concrete and reinforced steel. Depending on the composition of the secondary pile, the second pile wall can be a combination of hard soft, hard firm, hard hard. And you can see here, this is the installation method used for second pile. You use a sort of screw structure to screw down to drill a hole, and then just pour in the concrete and reinforcements and making the pile cutting to each other. This is basically the installation process. And for continuum pile, this is another kind of pile which is used to construct in ground retaining wall. It is consists of pile arrangement in a line, typically closed spaced. So they're different to second pile, which is they have a closer space in between two piles. On the other hand, the second pile is actually cut into each other. And the material of the continuous pile are concrete and reinforced steel. As you can see here, this is the main component and the diagram of what's the continual pile looks like from a plan. Continual pile contains board piles, reinforcement cage inside the board piles, and the possible use of grouting to seal gap in between the pile. And this is the installation process of the continual pile, as you can see the diagram at the left-hand side. And for the anchorage, the first type of the anchorage is a soil nail. Soil nailing is a ground stabilization technique that can be used grouted, tension-resisting steel or glass fiber composite elements to reinforce in-situ soil to create a gravity-retaining wall for permanent or temporary excavation support. The material of soil is normally thread steel bar or reinforcement, but maybe fiberglass sometimes. So the soil nail just made for soil. And this is the component of the soil nail, as you can see from the left-hand side of the diagram. The diagram shows the typical soil nail components, the steel bar, also called high-strength thread bar. This is the different types of the installation method for soil nail. And the other type of anchorage is rock anchors. Rock anchors, the major difference between rock anchor and soil nail is the rock anchor is anchored to the rock. It's a high-strength steel tendon, also known as strength tendon, placed along with a stressing anchorage on one end, whereas a means of transferring force to grouted rock on the other end. And the material of the rock board is fully grouted rebar. The strength tendons are made out of steel. The grounding agent is cement or resin. So this is the basic component of the rock anchor. The diagram shows typical ground anchor component. The component include bare plate and rock anchor for your choice. A drill or drilling bits, grouting materials, a retaining bolt, strength tendon, anchor head bolt. And this is the installation of rock anchoring. You first drill a hole, and second put the tendon stretch in and inject the grout. And also tendon stretch that after the grout obtain sufficient strength. After stretching the tendons, an anchor head will be installed, and at the end is tendon and anchored appropriately. And this is the third type inside the this is the third one, is a shotcreting. The main components of the shotcreting are cement, water, sand aggregate ratio, superplaster, and stabilizer accelerator. So the shotcrete is a concrete or mortar pneumatically projected at high velocity through a nozzle. So this is basically also to retaining the wall by using the liquefied concrete, and after the concrete gaining the sufficient strength to hold the wall at the back. And sometimes you can use a flush to make it more delicate, looks better. And this is two types of the shotcreting. The first is the dry mix process, and the second one is the wet mix process. This is a comparison of two different methods. And here's the typical application process of the shotcreting. Install tie backs, install mesh drain strips, apply the shotcrete at the final step. And here's the second main component that I want to introduce, is the dewatering system. So dewatering is a process of draining an excavating area at flood with rainwater or groundwater before construction can start. And the first type of dewatering system is open sump pump dewatering. It's a pre-excavation dewatering method. Groundwater is allowed to seep into the excavation, and it then collect in sumps and pumped away for disposal. Here are the main parts of an open sump pump dewatering. A sump or pit, riser pipe, sump pump, collector, drain, piles, low permeability, cutoff hole, settlement tank, discharge pipe work. And the second type is deep well point dewatering. Is an efficient way for medium to long-term dewatering for large projects. So that's the main difference between dewatering for deep well point and open sump pump. And here are the main parts of the deep well point dewatering on the ground to the surface of the soil. Soil is gravel and sand. Well point filter in well point excavation, riser pipe, suction header pipe. So this is for the suction deep well point. And single arm dewatering pump, settlement tank, discharge pipe work, generator, and electrical controls. Water collection remain pumped well. And this is the last type, which is a suction wall point dewatering. The only difference for this one and the deep wall point is that this one using the suction, or you can say vacuum of the groundwater mechanically to suck the water out. But the other one, the deep wall point, is using natural gravity for water. So for the third main component is main building foundation system. And the first one is the pile foundation. The pile foundation is a subtype of deep foundation. Pile foundation is actually a slender column or long cylinder made of materials such as concrete or steel, or sometimes timber, which is used to support the structure and transfer the load at desired depth, either by end bearing or skin friction. So the typical material for piling are precast concrete, in-situ concrete, steel, timber, plastic, composite. And this is the component of piling. Piling foundation are load, structure, superstructure, pile cap, raft, and pile. And this is the two types of pile foundation. First one is the end bearing pile. End bearing pile basically is the load passes through the lower tip of the pile. In another word, the loads are coming on the end of the pile. But on the other hand, the friction pile is normally used when the strata of the soil are weak. The whole resistance to the load of the pile are provided by the friction of the pile. So one is for the friction, the other one is the load are coming on the end of the pile. And the third type is the friction end bearing. So this is basically the combination of the two types pile before. So they use both the end bearing force and also the friction force. So the different installation process of the pile. This is the first one, is the screw piles. As you can see on the diagram, you put screwed in first, and then you put the you put the concrete and then the reinforcement. And this is the board pile. Board pile, you basically just put the you need to draw the hole first, obviously, and then put the pile in. So this is the basic rough installation process of the board pile. And driven pile, basically you just driven the precast concrete piles into the ground. And here's the floating raft. Floating raft is a land-based foundation constructed by excavating the soil. The weight of the structure built on soil is nearly equal to the total weight of the soil excavated from the ground, including the weight, water, and the soil before the construction of the structure. The float foundation is also a subtype of deep foundation. So the typical material for float foundation is concrete. The basement column is a vertical member in a building house. Primary function is to support the structure, a load, and transfer it through beams. Upper column transfer the load to the lower column, and finally to the ground through footing. So that's the diagram of the column and the concrete. So the components of basement column are column brackets, column capital, drop panel, pedestal, interior columns, exterior columns. As you can see, all the content is in the diagram on the left-hand side. And George will be introduce the following content.
Basement external wall and internal walls are the foundation wall that encloses a usable area under a building. The external wall consists of concrete masonry wall, floor framing system, and grout. The basement internal wall can also act like load-bearing walls and help maintain the structure integrity. The two typical types of basement internal walls are concrete masonry wall and brick wall. The core wall is the major support of mid- and high-rise commercial building in Australia, and core formwork consists of climbing formwork and shaft platform. Flat plate is one of the most simplified slab system, which contains a slab directly attached to the supporting columns, and there is no thickening in between. The material usually would be reinforced concrete and pre-stressed bars. Flat plate system is easily to construct. It has higher floor height, less cost of material, and less self-loading. It reduces the loading capacity of the floor. Next, flat plate. The system consists of main slab and thickening such as drop panels, columns head and column strip. Then the thickening connect to the column. The slab generally is pre-stressed or post-tension reinforced bar. There's more ceiling space, easy to construct and less load, other than the structure has beam support. However, it also decreases the span of the structure. Also, it has comparably less horizontally support and shear reinforcement. Reinforced flat plate has widely applied within the earthquake region. Band beam structure contains the main slab and continuous sectional beam along the one direction, which connect to the column. The tendons are generally post-tension to increase the resistance. Beam on the slab can be designed as different space and widths depends on the load capacity. And the wider beam, the thinner thickness. It also related to the floor height. There will be more punching shear and moment resistance should be considered along the two sides of the band beam as the potential risks. Hollow core slab precasting factory. The main components include the main slab and bearing units. The main slab contains a hollow core slab, a gap to allow grout pipe to go through. Also allow air and surfaces pass through. Around the main hollow slab, there are precast concrete columns and beams. Reinforcements such as column ties, beam ties, bearing bars, and mild slot will be used to connect each component. It is lighter and fire resistant. It is more convenient to install. The services such as electricity services. It requires less labor and installation process. However, hollow core slab needs more lifting cost, connection cost, and design may be not flexible. Solid slab consists of main post-tension concrete slab and concrete topping. The shear key on the sides provides a pathway to transfer load between planks. The thickness varies from 150 mm to 200 mm. Solid slab construction is faster, but performance is lower. A recent study shows generally solid slab is 20% less of loading capacity compared to the hollow core slab. Next, T-beam slab usually has horizontal flange as the main slab and webs connected to the bottom. Normally at the sides of the slab connection edge, there will be rebars and ties to resist tension and compression. Lastly, grout concrete on the top. Podium slab. It can transfer load through a steel or wood frame structure from the top of the slab to walls and columns below. Walls, columns, and other load-bearing elements of superstructure above podium slab may not align with the substructure loading-bearing elements below. This structure, also known as pedestal and platform construction, generally it includes multiple stories of wood structure on top of a single or multi-story podium of another construction style. And stage 2 is superstructure. And the columns, there are short columns and long column. Short column usually falls because the loading exceeds the ultimate stress. Long column fails caused by buckling, often material and design. Mid or high-rise commercial building columns use reinforced concrete. Within the concrete column, there are several rebars, which are hot rolling, where laid horizontally, and column strips ties rebars together. Beam are fixed beam or paint beam. The most popular beam is I-beam. It is lower weight but efficient carrying capacity. There are numerous dimensions of I-beam, such as 200 UB 29.8, and listed in the universe beam dimension and properties. The lateral torsion buckling could occur in the unrestrained beam or a beam of large unrestrained lines to reinforce the beam. Steel members such as fly braces and haunches could be used in the corner and support beams and columns at the same time. Besides, connections are used to prevent shear failure, bearing failure, and tearing failure, and axial failure. These connections are steel plates and bolts to connect beam and column together. Next, Emily will be discussing the external wall.
Hello everyone, I'm Yan. This part I will talk about external and internal walls, upper floors, and stairs in superstructure. Let's begin at walls. The walls are part of the main structure of the building, which is to support the ceilings and the floors, and also the building surface can pass through them, such as pebbles and electrical wires. The walls can be divided into two major types, external wall and the internal wall. The typical external wall is a part of the building envelope, while the internal wall is designed as separated rooms inside the building. The walls need to consider many factors as followed, such as wear resistant, waterproofing, and sound insulation. For the first picture, you can see the sound insulation is drawing at the green area is as required by NCC. And also you need to consider the outside. The cattle system is to cover the outside skin of the external wall. For example, window walls. There are many types of cladding in the second picture, such as attached system. It is directly attached to the building. In field system, it is installed between slab and columns. Support frame system firstly attach the building structure and then attach to the slab and the columns. The material of the external wall are concrete, brick, and the timber. The former building is LCT1. It is located in Australia, and its windows and the insulation have been installed with the external wall in the factory. There is a building called AM60 Office Development in Brisbane. Its internal wall is made of a double brick wall, which are connected with ties, and also it can be fixed with a concrete slab and other methods with bolts or steel shaft angle. The typical formwork system of external wall is composed of many parts, such as stands, ties, and the brace. The typical method is tail-up, which produces the precast concrete in the factory and then transported to the site and installed on-site. However, the surface construction method of the internal and external walls are different. Plasterboard is the most common one in Australia by far. The first picture shows that the insulation is installed to reduce sound, and also you can print color what you want on the surface. The internal wall material is similar to the external wall, which are concrete, brick, and timber. But for the brick wall is different. The internal wall is a single leaf and the external wall is double wall. For internal wall, it is generally adopt a model system to provide an efficiency method. The transform method can build vertical and horizontal members at the same time, especially for regular repeat structures. There are many components of formwork. For example, slab stop end and wall stop end. They provide as a stopper to return fresh concrete up to wall and the slab line, so the project process will build quickly. The precast concrete floor has been widely used in many high-rise buildings. The first picture shows the upper concrete floor, and the second is on the top of them the roof, or need waterproof on the external skin. There are many types of concrete floor, such as hollow core and solid floors. Formwork provide a horizontal surface and a vertical boundary. When the concrete bear the load, the bottom of concrete may happen cracks, so post-tensile concrete is a good way to solve the issue. It is formed by the using tendons. Tendons are consisted of stands coated with a protective coating and sealed inside ducts. Stairs are used to create a passage between the vertical floors. Trench is the place where is stepped on. Rise is the vertical distance between trench, and also have hand rail and landings. The material of stairs can be concrete, timber, and glass. The formwork of stairs are generally plywood or structural frame members, which are created by strap and low-grade timber. After building the basic stair, the finished materials may cover them, such as capping and tiles.
Through this assignment, we practice and learn the fact-finding, presentation skill, and reporting skills. Also gain a better understanding of the knowledge of medium high-rise building in Australia. In conclusion, this presentation shows the medium high-rise commercial building in Australia and divided into two stages, which are substructure and superstructure. The main material can be concrete, timber, and brick, and different materials suit different construction methods. For example, precast concrete for wall is produced in factory, and tilt-up method on-site. Through research of the key knowledge areas, we learn the material components and construction design for medium and high-rise commercial building in Australia. Thank you for watching.